Hey everyone, Mr. Phil's avatar here with another Devlog update. Today I'm covering a critical production deployment milestone for Stellar Throne, my 4X strategy game. For those new here, I'm building this with a dual engine architecture using Godot for the UI client and Zig for the high performance simulation engine. Yesterday's work was all about investigating production deployment of the Zig simulation and fixing critical parity bugs that I discovered during stress testing. Let me set the context. The Zig simulation engine is complete and provides a 52.7 times speedup over the original Godot implementation. All 1,069 tests are passing. But the question was, can I actually deploy this to production? And more importantly, what happens when I stress test it with real game scenarios? I started the day by creating a comprehensive parity testing infrastructure. This system runs the same turn through both the Godot and Zig engines and compares every single field in the game state to verify they produce identical results. I tested scenarios ranging from 10 empires with 10 systems all the way up to 100 empires with 250 star systems. And that's when things got interesting. The parity tests immediately uncovered 3 critical bugs that I had completely missed during development. These were real bugs that would have caused incorrect game behavior in production. The first bug was in resource validation. I discovered that the Zig simulation could create negative resource spirals under certain conditions. If a colony had negative food production, the resources would spiral further negative each turn, instead of being clamped to 0. This was a fundamental validation issue that affected the entire economic simulation. The fix was simple but critical. Add proper validation to prevent resources from going below 0 during calculations. The second bug was even more serious. The fleet upkeep parity was completely broken. I had implemented 2 different formulas in the Godot and Zig versions without realizing it. The Godot version used a flat rate formula. Each fleet cost 10 energy and 5 minerals per turn, plus ship maintenance costs. But the Zig version was using a per ship calculation that multiplied costs by the number of ships in the fleet. This meant large fleets would have massively different upkeep costs, depending on which engine you used. Completely unacceptable. I fixed this by standardizing on the flat rate formula in both implementations. Each fleet now costs exactly 10 energy and 5 minerals per turn, regardless of fleet size. Ship maintenance costs are still calculated per ship based on hull size and weapons, but the base upkeep is now consistent. But then the stress tests revealed a third bug. The ship maintenance costs weren't persisting after the stats through calculation phase. The fleet would calculate maintenance costs, then immediately lose them when the effective stats got recalculated. This was a data persistence bug where the recalculate function was overwriting the maintenance values with 0. The fix was to preserve the maintenance costs during the recalculation. These bugs led me to implement comprehensive stress testing. I created test scenarios with extreme conditions, empires with over 200 fleets, colonies with negative production chains, edge cases with 0 population planets. Every scenario uncovered more subtle bugs and validation issues. By the end of the stress testing, I had fixed 11 different parity bugs across resource validation, fleet upkeep calculations, population growth formulas, ship maintenance persistence, and infrastructure cost calculations. Each fix required updating both the Zig and Godot implementations to maintain parity. With all the parity bugs fixed, I moved on to the actual production deployment investigation. I attempted to enable the Zig simulation automatically during game initialization. And that's when I hit the real deployment blocker: initialization timing issues and async signal race conditions. Here's what I discovered. The backend switching triggers immediate game state serialization. But during early initialization, empires don't exist yet. The galaxy exists, but the empires array is still empty. So when the Zig backend tried to serialize the game state, it would crash, because there was no empire data to serialize. Even worse, I found an async signal race condition. The code was using async await to wait for a signal, but the async listening started after the signal was already emitted. Classic race condition. The turn would process, emit the completion signal, and then the code would start waiting for a signal that already happened. So the game would hang forever, waiting for something that already occurred. I fixed both issues. For the serialization problem, I corrected property name inconsistencies where the code was trying to access galaxy.galaxywidth instead of galaxy.width. For the race condition, I stored the signal reference before calling the coordinate turn function, ensuring the listener was connected before the signal could be emitted. I also added comprehensive deployment infrastructure. I created helper functions in GameScreen Core and Game Initializer for enabling the Zig backend at the correct point in the initialization sequence. I added debug logging to the turn processor to investigate any turn processing hangs, and I documented everything in a 343-line deployment guide. But here's the decision I made. I'm keeping the Zig backend disabled by default for now. The initialization timing requirements are complex. Empires need to be created first. Signals need to be connected in the right order. Rather than risk subtle bugs in production, I'm leaving it as manual enablement. The infrastructure is there. The performance is validated. But I want more testing before making it automatic. Let me give you the final numbers. I made 20 commits yesterday. The parity testing infrastructure added 4,243 lines across 13 files. The deployment guide is 342 lines of comprehensive documentation covering rollback procedures, monitoring, and troubleshooting. I fixed resource validation in simresources.zig, fleet upkeep in both the Godot and Zig implementations, and ship maintenance persistence in the stats calculation. The test suite now includes extreme stress tests, scenarios with 200 fleets per empire, negative production chains, 0 population edge cases. All 1,069 tests pass. Parity testing confirms identical results between Godot and Zig for all scenarios, and the 52.7 times performance improvement is validated and ready. Current status: the Zig simulation backend is production ready. All parity bugs are fixed. The deployment infrastructure is complete with automatic fallback to Godot if anything fails. The deployment is disabled by default until I verify the signal timing fixes resolve all initialization issues. Manual deployment is available for testing if I want the performance boost. Next steps: verify the signal timing fix works correctly in production scenarios. Test the deployment with real game sessions. Determine if automatic enablement is safe or if manual control is better. Either way, the Zig engine is ready. It's just a configuration flag away from being live. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.